an integral from 0 to 1 4 over square root of 4 minus x squared dx. Looking at this integral, we definitely recognize this as an inverse sine of x as an antiderivative. Because of that square root expression and 4 minus x squared. Okay, that means let's do a few moves before we apply the antiderivative. I will put that 4, which is in the numerator, in front of the integral, and under the square root I will factor out 4, and I will have 1 minus x squared over 4, because multiplying back 4 times 1, it is 4, 4 times x squared over 4, it is x squared. Okay, let's keep working with our steps. We still have 4, and then square root of 4 is 2, and I have under the square root I have 1 minus, and I will need the entire quantity squared, which, looking at x squared over 4, I can rewrite this as a x squared and 2 squared. X over 2 is my quantity that I'm looking for. Okay, now I think let's do one more thing. 4 and the 2 from the denominator I can also put in front of the integral. Quantity x over 2 squared. And I will apply the u substitution. Let me put the limits. I will let u to be x over 2. du is simply half dx, multiplying by 2 du is dx. Let's rewrite the integral in terms of u. The coefficient in front, 4 over 2, is 2, and we also have the coefficient 2 from the u substitution, and then integrand 1 over square root 1 minus u squared, and dx is 2 du, which I have my 2, the green 2, in front of the integral. Okay, 4, and then antiderivative of 1 over root 1 minus u squared du, it's inverse sine of u plus the constancy. One more thing. Oh, actually no, this is, I wanted to rewrite in terms of x, but we do have a limits of integration. Actually, we don't need a constant c. We need limits from 0 to 1. Oh no, no, we need a new limits. Okay, we need new limits. Let's see. If x is 0, then I need a new limit corresponding u value, which will be x over 2, 0 over 2, which actually it is 0, but it's my new limit. And then for the corresponding x equals to 1, u will be 1 over 2, which is half. Okay, so we do have actually a new limits of integration. Let's apply the fundamental theorem of calculus, and I will substitute the upper limit minus inverse sine and substituting the lower limit. For what angle sine is equal to 1/2? Of course pi over 6. For what angle sine is equals to 0? Of course 0. 4 times pi over 6, it's 2 times pi over 3, because I just divided by 2 both numbers. 2 pi over 3. That's the final answer. Thank you.